Hello, dear students. Today we will discuss about your work and energy chapter. So, first you must know what is work. If a force is applied to an object, if it displaces, it makes some displacement, then work is done. So, W is equal to Fs. That means work is equal to force into displacement. Okay? Displacement. So, today we will discuss about energy. Okay. What is energy? Capacity to do work is energy. Generally, energy is known as mechanical energy in general. So, we will discuss about mechanical energy. Okay. So, this application of work will come in certain places. That's why I am explaining about the work done. In science, work is done is something different in definition. Okay. So, if we do some work against gravity, it is called negative work. Okay. In that case, W will be minus Fs. Suppose we are going upstairs by a lift or by stairs. So, in that case, we are doing negative work. Okay. So, this is the direction of gravity, and this is the direction of gravity plus G, and this is the against gravity minus G. Okay. So, what is mechanical energy? Mechanical energy are of two types. It may be kinetic energy and potential energy. So, we will discuss these two types of energy today. Okay. So, what is first potential energy? Potential energy. Okay. So, energy, mechanical energy is generated as E, but potential energy is generated as EP. Okay. So, energy is equal to EP plus EK, and EK is the kinetic energy. So, first we will learn about potential energy. What is potential energy and its mathematical expression. So, energy a body possesses due to its change of position or position of situation. Okay. Position or shape. Okay. So, change of position or shape. A body that possesses some energy due to its change of position or shape is called potential energy. Suppose I lift the thruster to a certain height. It possesses potential energy. Okay. So, if it is on the ground, its potential energy is 0. But if we raise by applying some force, okay, equal to its weight, and taking it towards some height, it possesses some potential energy. We will discuss about its mathematical derivations. Suppose an object is there having mass m. I am lifting this object towards upward up to a certain height h. Okay. I am applying the force to this object mass m, and I am taking the object towards a height h. So I am doing some work. Okay. So the work done, you know, is W and it is Fs. How much force I am applying? Force is equal to mass into acceleration. But I am applying this force against gravity. So the acceleration is minus g, or acceleration is g m into g. Generally, force is equal to ma. But in case of gravitational or taking an object upward or making it downward, instead of a, g is used as gravitational potential. Okay, it is the acceleration due to gravity. It is general acceleration, but it is acceleration due to gravity. So when object moving upwards or moving from upward to downwards, the g is used. But in general case, if it is moving in simply in ground, then a is used. Okay. Okay, so if I am lifting this, I am doing some work. Okay, so work is F into S. So F is how much? Mass into acceleration, and here the acceleration is g instead of a. That's why I am writing mg for F. So F equal to mg and F equal to ma also. Okay, during movement in the ground, ma. And during upward downward it is mg. So the s is the distance travelled. So here the distance travelled is this one, this much. But I am taking this distance as height. So I can write the total distance travelled h s h. Okay. S h, because the distance is s, but it is a height, so I can write h. So this is the potential energy. Okay, W equal to mgh. Okay, this is the definition. W equal to mgh, or EP equal to mgh. This work done is equal to potential energy. The work done that by my hand to place the duster to a certain height, to raise the duster to a certain height, is the potential energy. So it gains some energy by working on this duster. It gains some energy, and this energy is called potential energy. That's why EP is also mgh. So potential energy depends on what? Three factors. What is mass, and this is acceleration due to gravity, and height from ground. This height is height from the ground level. Okay, those three things, they are dependent. Okay, let's discuss to the kinetic energy. Now let's discuss kinetic energy, EK. Okay, suppose a object of having mass m, okay, is moving with A. Okay. Suppose in the beginning its velocity is u, initial velocity. Suppose its initial velocity is u, and after applying a force, suppose its final velocity is v. Okay. An object. What is kinetic energy? Let me define first. A moving object possesses energy called kinetic energy. The energy possessed by a moving object or possesses during its motion is called moving energy. The energy that is present in a moving object or during its motion is called kinetic energy. Okay. So kinetic energy only can do work. So suppose we applied a force F, and it moves some distance s. Suppose it covers some distance s after time t. Okay. After time t, suppose it moves some distance s and its final velocity is v. Okay. So final velocity is v. See what I am repeating these things. Suppose there is an object having mass n, okay, at rest, and fast, but if it is moving with an uniform acceleration a, suppose its initial velocity is u and final velocity is v. It travels some distance s in time t. Okay, you have to write down first this. Then you know, according to our equation of motion, what it says, v square equal to u square plus 2as. Okay, so if I take this v square, u square, this side, it will be minus u square equal to 2as. Suppose I am taking this a. Okay. If s is be calculated and I am v square minus u square, this 2a will be, this is multiplied here, divided here. So remain the value of s is v square minus u square by 2a. So kinetic energy, the work done by a moving object, is its kinetic energy. When an object is moving, when it comes to rest, the work done by till it's coming to rest is called its kinetic energy. Okay, is equal to its kinetic energy. So work done is how much? Work done by that W equal to Fs. Okay, F can be written as F can MA and S can be written as this V square. I am putting the value of S, this value from third equation, V square minus U square by 2A. Is it visible to you? Okay. Now A can be cancelled. Okay. What is down here? W equal to m by 2 v square minus u square. Okay, or equal to half m v square minus u square. This is the kinetic energy. Okay. Suppose the body is at rest. In the starting, the body is at rest. In that case, the initial velocity u will be 0. If the body is at rest, okay, or the object, if the object is at rest, u will be 0. Think. So, what will be the work done? Half m d square minus 0. That is half m d square. This work done is equal to kinetic energy. So, Ek is half m d square. So, this is the kinetic energy equation. Okay. So, kinetic energy depends on which two factors? Kinetic energy depends on mass and velocity. Mass and velocity. If an object, if the mass of an object is 2 times more, then what will be its Ek? Ek will be how much? Ek will be 2 times also. Suppose if the velocity of an object increases by 2 times, what will be its Ek? Suppose the velocity of an object increases by 2 times. What will be the value of Ek? What amount the Ek will be increased? Who can say? It will be increased not in 2 times like mass. It will be into 2 square, means 4 times. Okay? If the velocity of an object increases by 3 times, okay, if it increases by 3 times, means velocity will be 3v. So how much Ek will be increased? This part 3 square, 9 times. Okay? Ek will be 9 times more. So this video is up to this video. We will discuss something new in our next video. Till then, bye. Thank you.